So good morning, and thank you for being here. Thank you for being this day of training. We prepared some technical content for you. The first section of each track is more high level. It's trying to give you an overview of what is happening in that space. And then we are going to dive deeper in the next section into specific topics. So my name is Danilo. I'm part of the Evangelist team, and I'm focused on serverless. Always, since 2014, since we launched AWS Lambda, I've been interested in building event-driven serverless architectures with our customers. And the idea today is to share some of these best practices and some of the new things that we launched at re:Invent. I also wrote a book on AWS Lambda that has been translated to Chinese and Korean. And I worked with my publisher to create a free ebook. So the last book that you see on the left here is a free ebook, so you can just grab it. It gives you the foundational knowledge of what you need to know to set up an agile serverless team, what is a web API, what serverless means, and how you can use it. So this is one of the mandatory slides when you talk about serverless to set the context. So what do we mean by serverless? We mean an architecture where you don't need to provision or manage servers, storage, and infrastructural resource, where scaling is automatic, so you can build something that you use once per month or thousands of times per second, and you don't need to change anything on the configuration. Everything is highly available and secure. So we have a session today on multi-region where we dive deeper into what availability means and how that works for serverless architecture. But the idea is that when you create even the most simple hello world function with Lambda, everything is replicated across all the availability zones that we have in a region. So for example, here in Dublin, we have 3 availability zones. Each of those is 1 or more data centers. So if you say you create just a 3 lines function that says hello world, this is replicated across 3 data centers and then can scale automatically. And then you should pay for value. So for example, with Lambda, you only pay by the number of invocation, by the hundreds of milliseconds of execution time. With storage like S3, you pay by the space that you use, and also by the number of times that you interact with this data, the time that you read the data, when you write the data. So this is really the approach that we see for a serverless architecture. And the main advantages that we see are, of course, cost reduction. We've seen lots of customers that reduce the cost from 30 to 90% easily by moving from a traditional architecture to a serverless architecture built with building blocks like AWS Lambda, Amazon S3, and DynamoDB. But we also see elasticity, so the capacity to build something when you are not aware of what will be the workload. So maybe you are a startup, or maybe you're creating a new product for a company, so you really don't know in advance how many users you will get, how fast your product will ramp up. But probably the most important advantage is agility. And agility means that you are really able to build your idea faster. You can really go to market faster because you don't need to spend time thinking about everything that is surrounding and supporting the building of your idea. For example, at re:Invent, the conference that we had in Las Vegas just a couple of weeks ago, Capital One, a large bank that is, I'm not sure if they operate in Ireland, I don't think so, but they operate, for example, in the UK, and they are quite big in the US. And the team of Capital One was telling me that for them it's like having 30% more time per week now that they use serverless. So if you think 20% more time every week is really a lot. And the idea is really to focus on what is going to be different in your solution, not on everything that can be easily shared across different implementations. So normally we see that customers, they spend maybe 60–70% of their time in just repeating the same configuration, in managing databases, managing compute clusters. These are things that maybe when you are developing are not so critical, but when you're in production can really suck your energy. The idea when we think about these new products is to create an environment where you can really focus most of your energy, like 90% of your energy, on building the unique features that you want to create. and just a little bit on managing the configuration and the infrastructure that you need to support your application. And the serverless portfolio has grown over the years, and it's quite broad. So lots of services have some simplification that we can use, and we can think of them as serverless because we don't need to think about the servers underneath. Some of those are probably the one that come to mind easily when you think about serverless, like Lambda, API gateway, step functions, the serverless application repository. And today we will probably dive deeper into those services, but we will see also how the other services fit into this landscape. So let's see what are the trends that we see in serverless. So we now have lots and lots of customers, hundreds of thousands of customers using, for example, Lambda every month. And just at re:Invent, as I mentioned, there were a couple of banks from Europe talking about how they use serverless architecture in the financial market. That is one of the most regulated markets. So Capital One, that was speaking in my session, and also HSBC. For example, Capital One was describing how they use Lambda for building one of the most critical public API that they have. So they have lots of APIs, but only a few of those are public. They are a bank, of course. And one of those is called the Credit Offer API. It's an API that Capital One is using to advertise their credit cards. And those websites that do comparison and then suggest which is the best maybe product for you, they are using this API to suggest and advertise the credit cards to their customers. And then from this API, they start the registration of new customers, of new credit cards. So you can imagine how critical and how business critical is this interface for them. And this was built with a traditional architecture. So they were deploying once per week. Of course, it was 2 a.m. on Monday. That's probably the moment of where there was less traffic. And just that is probably burning energy of a couple of people of your team that must be there every week for the rollout. They migrated to Lambda, and they start to use safe deployments. It's one of the features that are part of the AWS Lambda, where you can automatically do canary deployments when you create a new version of a function. And now they deploy in production during workday, roughly 2 times per day. And they don't need to go during the night anymore. And this is probably one of the reasons why they feel that it's much more faster for them to iterate and add new features for their customers. And when we look at customers, this is probably the standard adoption that we see. We see lots of enterprises adopting serverless and maybe leapfrogging all the evolution of the technology in the last years. And often they start with very simple scripts that they run on Lambda, something that normally maybe you run on a server to automate infrastructure management. And they migrate this to Lambda. They can use features like CloudWatch events to schedule those recurring cron jobs that now are Lambda functions and are much more controlled and available than before. And in this way, they start to understand how it works, what are the advantages of this approach. And then they start to create auxiliary applications. The idea here is that, especially with microservices, but even if you have a big monolithic application, when you need to add a new feature, instead of changing the main application, you create something external that maybe is managing some interface. For example, maybe your customer are uploading some documents on Amazon S3. You trigger a Lambda function that is processing these documents and maybe indexing the information in your current database. So this is a minimal change to your architecture, but you start to have something serverless surrounding your traditional architecture. And then when they get the advantage here, they move into business critical application, like the example that I mentioned of Capital One, where really things are critical, where time-sensitive, having a time-sensitive answer is important, high availability, and probably processing data at speed is really important. So this is a very common maturity model that we see with our customers, especially enterprise customers. And in this way, we've seen lots of use cases that from Thomson Reuters, that probably was one of the early adopters of Lambda. They wanted to know how their customers were using their products, because when you give products to your customer, you want to understand what features are used, what are not. And they use Kinesis to collect this information, and then Lambda function to process this information in almost real time. And in less than 10 seconds, they update a dashboard that shows to their leadership how their products are used in real time. So this is quite an interesting use case, again. And we have FINRA. This is a financial authority in the US. They monitor every stock transaction. So they now process 500 billion of validation every day using Lambda function. And they're super happy because the stock market is not stable in the number of transactions. There are days where there are very few transactions and moments in time where there is a huge peak of transactions. So managing this scalability for them was very complex in the past. Now this is managed by the platform for them, and they can focus on the logic of the validation that is really their core business. Another customer that is using Lambda in an interesting way is financial engines. They do portfolio management for customer, but they do that not just with humans. They automate that with some computational process. They use an integer linear programming optimizer on Lambda. And in this way, they were able to scale and manage lots and lots of new customers. It's much easier for them to manage and automate portfolio management with this new platform that they built. Probably you know National Geographic. They have a huge catalog of multimedia content that grew over the last 130 years. And they wanted to make this portfolio of content, this multimedia content, pictures, movies, available easily online. And they built a serverless platform to do that. And they also use features like Amazon Recognition. Amazon Recognition is an AI service that is fully managed. So you don't need to do anything. You just need to provide a video or an image, and we can extract features from this image. What's the content? What's the faces? What's the sentiment of the faces? And they use this to augment the information they have. So they upload the content to S3. This triggers a Lambda function. And they analyze the picture, and they extract more information that they already have on this picture. And then they index this information on DynamoDB, that is their main online database for serving content. Autodesk is probably more of a use case, similar to use case that I showed before of internal adoption. You probably know them for software like AutoCAD, and they are transitioning to a software as a service model. And what they do is that they want to empower their users, their developers, with an AWS account so that they can experiment and build things faster. But creating an internal AWS account, a sort of sandbox that their developers could use, was taking almost 2 weeks, because there were lots of human checks, approvals. So they built an internal tools that automates all the checks and all the approvals. So now in less than 10 minutes, they can provision a new account to one of their developers that can immediately start and be productive on a new idea and build something that then can possibly go in production. And we also have a growing ecosystem of partners. So I'm not mentioning all of them because there are a lot, but we really work closely with our partners. They usually add new features, add new capability for observability, monitoring, management to our platform. And we work so closely with them that, for example, when we launched some of the new features at re:Invent, we worked with them before, so they were able to add the support for this new feature on day 0. So immediately when this new feature was available, they could manage and monitor or process this new feature transparently for our customers. So at re:Invent, we had a few launches, so new features that we launched in the serverless space. And the idea for us was to try to cover those that are our main priorities. So first, we, of course, still want to continue in excelling in service fundamentals. So for the core services, we want to add features that can enable the fundamental characteristics that you expect of availability, latency, security, and scale. We also want to enable new application development patterns. We saw over the years that when we launched a new service or a new features, new use cases became possible, and we started to see customers doing things differently. So this is something, again, that we want to continue. We want to continue to minimize undifferentiated code. So our goal, our ultimate goal, I would say, as AWS is really to help you write just your own business logic. Everything else that is not unique to you should be something that you can take off the shelf and integrate with your application. And finally, we want to empower the developers and the operations team that is managing a serverless architecture so that they can really easily go in production and manage the application in production. So let's start with service fundamentals. And during 2018, we worked a lot on this feature, on core features. One of those is service compliance. So all the core services for AWS architectures like the API Gateway or Lambda are now compliant with PCI DSS, so they can be used for payments, with HIPAA for healthcare, and we added other services to those compliances. Last year, especially before May, we were strictly focused on GDPR, and all AWS services were ready for GDPR in May when GDPR started to be enforced by the law in the EU. And we also worked on core features of our services. So AWS Lambda now has an SLA, so that shows how much we are really trusting this platform. AWS Lambda is now what we call a tier 1 service because it's used by other services in AWS when we build them. So internally to other services, we use Lambda. So tier 1 services like Lambda, S3, DynamoDB, they must be in every region because it's really critical, because otherwise we can't deploy other services on top of them. We also continue to reduce the price. So the API Gateway, we introduced a tiered pricing model. So with the API Gateway, the standard price was $350 for 1 million of API requests. Now we added tiers, and if you grow and you have lots of millions of API calls, it goes down to 1.51, so less than half of the original price. This is, of course, only for high volumes. We also improved internally some of our services. For example, step functions. Step functions is a way to manage workflows in the cloud when you have some complex business logic that you want to map in what we call a state machine. So if you studied computer science, it's really the idea of state machine in computer science, where you have a state and transitions, and this state evolves towards a goal. And we improved internally how step functions work, and now they are much faster. They can have up to 1,000 transactions per second. So it can be used in use cases where it was not possible before. An interesting launch that was not only for Lambda, but that we use for multiple services is Firecracker. So Firecracker is what we call a microVM. So the idea here is quite simple. So when we were executing Lambda functions before Firecracker, in the last 4 years, I would say, we create sandbox environment where we run the Lambda code of every customer. And to do that, we use the same features that are used by containers to partition a servers, like C groups, for example. So these are operating systems, Linux primitives that we use to enforce and create a sandbox. But we were not trusting this sandbox for security. So even if it was not public, we never ran 2 functions of 2 customers on the same virtual machine at the same time, because we were not trusting the security. So it was quite inefficient for us to run Lambda functions in this way. So that's why we developed internally Firecracker that is used by Lambda, and it's used also by Fargate, so the serverless container that is in the other track. So I'm just barely mentioning it. But the idea of Firecracker is a microVM that now runs on EC2 bare metal instances, so where we have direct access to the bare metal of the instances. And those microVM can start very fast, so they start in less than 125 milliseconds. And of course, this is not affecting cold start because we can pre-provision the VMs before you start the function. They are ready to be used. And we can start lots of VMs. So we can start 150 micro VMs per per second, and we can have thousands of microVMs in a single physical server. So it's much, much more efficient for us to do that. And Firecracker, that is used by AWS Lambda, it's used by Fargate. It's open source, so we release it in open source with an Apache 2 license. So if you're interested, there's a very nice page and GitHub repo with a Slack channel, also if you want to interact with core developers. And we are now working to integrate Firecracker with other environments and other open source projects. So this is really improving the way we can manage security with Lambda functions at scale in an efficient way. What about new development patterns? So here we, during this year, we integrated SQS as an event source for Lambda, so our message queue. It's a very efficient integration, so if you need to process lots of message in a queue asynchronously with a Lambda function is definitely a new pattern that you can use. We also improved the integration with Kinesis, our streaming platform. Previously, since with Kinesis you need to preserve order, we were using only a single Lambda function, so that could be a bottleneck, and there were some patterns to overcome that, but it was complexity on your side, on the customer side. Now you can have up to 20 Lambda functions consuming the data from a single Kinesis data stream, so it's much more efficient. And we also now support the new HTTP2-based interface of Kinesis that is much faster than the previous HTTP 1.1 API. So this is much, much faster to process. We also saw, over the last couple of years, different kind of workloads on Lambda. We've seen more heavy data analytics workloads being moved into the serverless world. So that's why we increased the timeout of functions from 5 minutes to 15 minutes so that you can process more information. And we also doubled the maximum payload that you can pass to a Lambda function when you invoke it asynchronously. So it's now 256 kilobytes. Of course, if you need more data, you can still store the data on S3 and give the link to S3 to the Lambda function. This is still working, but if you need speed, you can now send more data directly in the invocation of the function. On the API, we also worked to improve how you can create APIs with the API gateway, on the policies, on how you can use custom authorizers across accounts. We increased the limits of the APIs, and we also introduced private APIs. So the idea is that the API gateway now can be used really for lots of different use cases because it also supports private APIs. So you can receive an API request from the internet, and this is what we call an edge-optimized API. That means that it's automatically optimized by using our content distribution network with CloudFront. Or if you prefer to be regional, so you don't want to have this kind of optimization, but you want to really get out of the internet specifically in one region. For example, you want to get out in Ireland or you want to get out in Frankfurt. You can use the regional APIs. Or you can now, with private APIs, serve private APIs within a customer VPC, between a virtual private cloud, so between a virtual data center that you build on AWS. So this is a new use case when you build microservices, for example, and you create internal APIs. You can serve them through the API gateway with all the advantage of API management that the API gateway provides. And on the other side, the destination can also be the internet. So you can call as the integration, what we call, so the implementation of the API, anything that is available on internet at regional level within AWS or within a customer VPC. So this really, and you can have lots of different permutations here, so it's opening lots of different use cases for the API gateway. One of the launch that we had at re:Invent was related to workflows. Managing business workflows, I think, is critical for companies. In Amazon, we have roughly 20 different workflow engines because everybody is opinionated on how they want to manage their own APIs. Even in AWS, we have probably a couple of services in this space, but the most recent and probably the most easy to use is now step functions. And with the step function, you define this state machine where the state is transitioned through tasks, and mainly tasks where Lambda functions or activities that run outside of the platform. They can run on containers, on EC2 instances, or even on premises. This was before reInvent, but we saw that lots of the time there was similar integrations. So we launched native integrations with lots of different services. So you can now, from a step function, have a task that starts an ECS task on Fargate. And this is normally an asynchronous operation. So you launch a task, and it can take 1 second or 3 hours. And normally you need to check for the state. All this complexity is now managed by the platform. So you call those asynchronous invocations like they were synchronous. So you say, start this task. When it ends, send me back the result and go to the next step of my state machine. And the same for AWS Batch. AWS Batch is a batch engine for batch processing. Normally it's used heavily in industries like oil and gas, but anytime you have a large batch analytical workload that you want to optimize and execute, AWS Batch can help you provide you the necessary infrastructure. It's container-based. It's a very interesting management platform. Also, Amazon SageMaker. It's the platform that we created for developers to use and build and machine learning models. You can now start the training of a new machine learning model or apply a machine learning model to a batch set of data set from a task in the step function, in a step function state machine. Glue for managing ETL processes. And you can also directly read and write from DynamoDB. So for example, if you want to read the configuration or update some information on DynamoDB as the result of your step function. And also, you can publish a notification on SNS, our notification platform, or you can insert a message in a queue. So these two integrations are really helpful if you want to integrate maybe a state machine with an external product or an external service, so using traditional message queuing or publish and subscribe technologies. So now step functions can use tasks from all of those services natively, so you can really reduce the number of lines of code. And for all those the asynchronous invocation, we are managing the asynchronous call and waiting for the result. So for example, this was a classical example of a state machine submitting a job somewhere, maybe on AWS Batch or on containers. So you were to submit the job, but then wait for some seconds, check if the job is still running, and then if it is complete, you go on, otherwise you wait another second. So this was the way of polling a traditional asynchronous invocation. Now that those are integrated natively, you just say start an asynchronous batch job. When it's finished, if it's finished correctly, do this. If you get an error, do that. It's much, much easier to visualize the logic of your state machine. Another integration that we launched at reInvent was for Lambda with the application load balancer. So normally, to provide an HTTP interface to a Lambda function, you were to use the API gateway. There is also a native Lambda invoke API that you can use, for example, but you must use the AWS API syntax. Now we also provide the possibility to call a Lambda function from an application load balancer. And there are two main advantages here. From an enterprise or a company integration point, the application load balancer is supporting security groups and VPC networking. So it's much easier for a company that is already using a VPC-based infrastructure to integrate the application load balancer and then eventually call a Lambda function in the back. So the integration is simpler. And if you want to migrate a workload from a traditional architecture to serverless, you can use the strangle pattern. So maybe you have your application load balancer that is calling a traditional infrastructure on EC2 or on containers, and then you can introduce Lambda and move the workload to Lambda without changing the interface for the internal consumer of the application. From a price standpoint, I didn't do an extensive comparison, but the application load balancer, you pay mostly by the time. You pay by the time plus also the computation of that is required by the data. So what I expect is if you have a high volume of API calls And those API calls have a small payload because maybe you don't need to move a lot of data. Then probably the application load balancer can also be cheaper than the API gateway. So high volumes with small payloads, it could be quite an interesting use case. This is something that we pre-announced at re:Invent. It's still not available, but we're working hard. This week we also have a webinar in the US specifically on this topic. So the idea is to provide a native WebSocket interface to the Amazon API gateway. So normally the API gateway is receiving API call using the HTTP protocol. But we see lots of use cases where you need a real-time bidirectional communication between the client consuming the API and the API gateway. Normally, now you can do that with some hacks. For example, some customers, they use AWS IoT without physical IoT resources to do that. But we think that this will be much easier. So the idea is that the API gateway will manage the stateful connection for WebSockets with the client, so mobile app, web application, IoT devices. And then there will be the traditional stateless architecture in the backend where the API gateway can call, depending on the API call, a Lambda function or something running on EC2 or an external API. And in this case, we will pass an endpoint that the backend, for example, the Lambda function, can use to publish messages back. So if we receive a message on the WebSocket, we send it, for example, to the Lambda function, and we also give the endpoint that the Lambda function can use to publish messages back to the platform so that they can push information using WebSockets to the client. So this is quite interesting. We're working on releasing that very soon, and if you're interested, as I said, there is a webinar this week. Minimizing the code that is really not unique for you. Here we launched something that probably is one of my favorite launches at re:Invent. It's Lambda layers. So normally with Lambda function, you were to when you were to create a function or update a function, every time you need to build and take all the dependencies and put them in the zip file that you use to upload your Lambda function to AWS. And even if the same code is shared across Lambda function, you were to do that for every Lambda function. Now you can create these layers that provide a shared container that is can be referenced by multiple Lambda functions. And this is giving a couple of advantages because now deployment of updates is much faster. You just need to update the function code and don't upload the dependencies. And it's also creating new roles and responsibilities because maybe companies, they can have standard layers that can provide with management and security modules that you might need to use. But we will dive deeper into that in the next session. So I'm just spending a few words here. Another interesting launch was nested applications for the serverless application repository. And the idea here is that we created this repository where you can share whole serverless applications that solve some specific problem. And you can share this application internally to your account within a company, or you can share application publicly. And what we see is that customers, they want to share also components that they can use together to simplify the implementation of any application. So now when you create a serverless application, you can at some point reference a whole application or application component that is on the repository and integrate that with your application with like a few lines of code. And you don't need to copy and paste those applications inside your code. You just say, here I want this application solving this specific problem, and this is the way to integrate this component with my application. This is quite a strange concept, I understand, so that's why at the end I have a better example that can put this into context. But I think it's really one of the most powerful announcements. What about developers and operations? So here we worked this year to add support for new languages. So during 2018, we added support for Go. Go is quite an interesting platform for Lambda functions. For example, Capital One the use case that I mentioned before. They started with Java, mostly to recycle what they already did internally. But then they migrated to Go for two main reasons. One was that they wanted to experiment with the new features of Go, and also they wanted to reduce the effect of cold start that can be a little bit higher with the Java platform. The JVM 8 has not been designed for short-living process. So they get better performance, and they also told me that the developers are much happier, no? Because in large companies in the past, you were used to work always on the same stack. No? You work for a company that is using Java, and you work with Java your whole life. Now, the idea that you create these smaller components like microservices with Lambda functions, and you can use different toolkits, different languages, is really an interesting perspective for them. We also added updated support for .NET Core to version 2.1. We added native support for PowerShell scripts. We recently updated also the Python engine to the latest version, to Python 3.7. And we also work to simplify the way you use the API gateway. So for example, if you want to create a developer portal inside your company where you share your APIs, you advertise the internal APIs, we created a framework that you can get from GitHub. It's open source, and you can use it off the shelf or customize it if you need it. We integrated the API gateway with the web application firewall natively, so it's much easier now to protect at layer 7 your API from different kind of attacks. We integrated the API gateway with AWS X-Ray for tracing and monitoring of your serverless architectures. And we also work to improve tooling. So for example, if you want to create a Lambda function and expose the Lambda function with the API gateway, now you can do everything from the Lambda console. You don't need to go to the API gateway console. It's just really an easy configuration. We completely rewrote the old SAM local. It's now called the SAM CLI, the Serverless Application Model command line interface. It's open source and can now debug also other languages. At the beginning, it was debugging Node.js and Python, and now it can debug also other languages such as Go. And also, we improved how you search application on the serverless application repository, and we also added support for new components in SAR. So now, when we created SAR, we try to limit the number of things that you could use in an application that you would share because of the security implication. If you start a serverless application from SAR, it's installed inside your account. So it's something that we wanted to really understand the impact of. And now that we're getting more experience, we added support for other features that we think can really help the creation of more complex applications, such as step functions, glue, SQS, and so on. Here, the big launch was probably the support for Lambda now for custom runtimes. So we created a standard runtime API, and you can use this API to bring anything that can run on Linux as a language that you would like to use with Lambda. You can use this to add new programming language or to add specific version of programming languages that maybe we don't support. And this is also the new API that we are going to use for new languages that we support natively. For example, at re:Invent, we added support for Ruby. So now Ruby 2.5 is natively supported as a runtime with Lambda. And this is it is based on the runtime API, so the same API that you can use to add support for other languages. And we work with our partners to add other platforms, such as PHP, Erlang, and so on. And we will dive deep into the runtime API in the next session. And the idea is that you can also use layers to distribute runtimes, so it's much easier to use also those. To simplify the management and the development of application, we now have an application view in the Lambda console that shows you the whole serverless application taken from a CloudFormation, all the components, the functions, the other components that you use, such as DynamoDB tables or S3 buckets. And you also get the overall monitoring of your single applications. So it's an interesting panel. If you have a serverless application that is built using CloudFormation, that is implemented using CloudFormation, it's really a nice way of monitoring that application. And we also created new toolkits for IDEs, because every developer has their own favorite development environment. So it's now generally available, the AWS toolkit for PyCharm, and we have a developer preview for IntelliJ and Visual Studio Code. Those developer previews are available on GitHub because all those toolkits are open source. And the idea is that if you use PyCharm, IntelliJ, or Visual Studio Code, you really want to help you have an integrated environment where you can monitor, deploy, debug locally, and run locally or remotely serverless applications easily. What are other important launches? So there were a few other important launches that I think are relevant for the serverless space. The first one is DynamoDB on demand. So anybody here using DynamoDB? Okay, so you know that with DynamoDB, normally you have to set the throughput per table. And you have to say how many reads and how many writes you need for each table per second. And then we will manage the infrastructure for you. And then you pay by this throughput. The idea is that lots of customers, they don't know exactly how much throughput they have. Maybe they have workload with spikes, maybe periodic spikes. And this was not really easy to manage. So now we introduce a new capacity mode. So you can now use the not just the standard provisioned mode, but also the on-demand capacity mode. If you choose on-demand, your table can scale to thousands and thousands of transactions per second without any configuration, and you pay by the exact number of reads and writes that you have on your table. So from a management perspective, you really don't need to do capacity planning. To give you an idea, if you need to go, normally the limit that you have in capacity is the limit of your account. So if you go into your account, you can see the maximum number of reads and writes per second that you can have with your DynamoDB table. If you need more than that, you can open a standard limit case with AWS to increase the limit, but you really don't need to do capacity planning anymore. From a price point of view, this is most of the time cheaper. But if you have a very stable workload, so if you can get closer to the throughput most of the time, then the traditional provisioned approach is still cheaper. But if you have anything like spikes, or you really don't know, or you don't consume most of your provisioned throughput all of the time, then probably the capacity mode is cheaper. Good news is that you can enable and disable this and change this flag in your table once per day. So if you want to test, you can just enable it, test it, and then go back if you see the price is higher or if you don't like it, or you can stay on demand for as much time as you want. When I also tried, for example, in the blog post here for DynamoDB on demand, I built a serverless application with the API gateway, Lambda functions, providing a sort of REST interface to DynamoDB. And then I started 1,000 Lambda function in parallel for 60 seconds, literally bombarding DynamoDB through the API gateway with requests. Each of those 1,000 Lambda functions were running multiple requests in parallel. And I reached a throughput of 5,000, so 4,000 writes per second and 1,000 reads per second in 60 seconds. And this is not a benchmark. It's something that just I started without any ramp up. So from zero, all the functions started at once, ran for 60 seconds, and then they terminated. So it gives you an idea of the flexibility that you get from the on-demand platform. Another super interesting announcement for DynamoDB is the native support for transactions. I do believe that DynamoDB is, I think, really the only NoSQL database that has such an advanced support for transactions now. And you can now create transactions across different tables in the same region and in the same AWS account. So the only limit is the region and AWS account. And you can create transactions within a single table or multiple tables. And the way it works, you have something like transact write items, where you say, I want to start a transaction. Then you can list the updates, the inserts that you want to do. If you need to, and each of these updates and inserts can also include conditional checks that must be valid for the transaction to succeed. And if you have a check on an item that is not updated in the transaction, we created a new statement that is a conditional check that you can run. So for example, if the value of this record in this table is greater than this, then update these other 3 records in this other table. This is an example that I built for like the idea of a game where you have an items table. Let me zoom a little bit here so that you can see it a little bit better. So the idea here is that you have a table with items that players of this game can buy, for example. And here, if you want to buy, what I do, I want to update the items table. The condition is that the item is available. If it is available, then set available to false and set the owned by property with the player name. And then in the players table, I need to check that the coins of the player is greater than the price of the item. And if this is true, then set the coins equal to the coins minus the price, and then append this item to the inventory list, because DynamoDB has document support, so you create an inventory as a list of all the items that the player has bought. And for this transaction to succeed, you need the item to be available and the player to have enough money to buy the item. So building the same things without transaction is possible, but puts lots of complexity in the client development, because you normally need to do multiple steps and to coordinate these activities across tables. So now it's much, much easier. So I'm really looking forward to see what you're going to build with transactions. From a cost point of view, any write in a transaction counts like 2 traditional writes from a throughput perspective or from a capacity perspective if you pay on demand. This is because, of course, we need to prepare the value and then update or roll back in case the transaction goes on. And this is a transaction, so these 2 updates will either be successful at once or they will not, so neither of those. So it's really a big simplification for using DynamoDB for complex processing. If you need to do financial transactions within DynamoDB, now it's much, much easier to build something really resilient. And another announcement that I think was interesting from the serverless space is in preview currently. You can apply to the preview, is the new S3 batch operation for object management. So what we saw is that sometimes customers, they don't need just to react when you upload something to S3. Maybe they want to run something on data that is already on S3. They want to run a batch operation on a large subset, if not on all the objects that they have in an S3 bucket. So that's what the new S3 batch operation supports. You can do different operations, not just Lambda function, but the specific use case is you can run a Lambda function for all the objects or a large subset of objects that is on S3. You provide a list of files, or S3 has natively the support for inventory. So you can, during the night, S3 can daily create an inventory of your item, and then you can say, apply this Lambda function to all the objects in this inventory, or to all the objects in this list that I provide. And we will manage all the execution for you, and you can process millions, if not billions of items very easily, something that normally requires lots of customization on your side if you need to reprocess lots of objects. So in this way, if, for example, if you get an S3 bucket with lots of documents or images and you want to process all of those to index the metadata, you can very, very easily do that with the new batch operation. Let's go back to the nested apps to give you an idea why the nested apps for the serverless application repository is quite interesting. So the idea now is that if you have something recurring, a recurring problem, we can just create the component and reuse it. For example, a very common use case is reacting to social media. Lots of customers, they say if something happens, for example, on Twitter, there is this specific handle or this specific search on Twitter, I want to do something. And the something is custom. Some people want to store the tweet or analyze it with sentiment analysis. Other people want to just automate and create a reply on Twitter for the automatically. So we created, as an example of how you can use nested application, a component that is in the serverless application repository that is called the Twitter event source app, that is automatically implementing a polling using CloudWatch events, so that, for example, every minute this component starts, search on Twitter, And it's also storing the checkpoint, because the Twitter API is like a stream, so you need to store the checkpoint so that you are sure that every time you search from the previous checkpoint and you don't miss messages. And the idea is that this runs, for example, every minute, search for some strings, and then if you find something, you pass it to your own custom Lambda function that is doing what you want to do with these tweets. So the only custom code here is in this Lambda function. You don't need to rebuild this every time. We provide this as a component. There will be a session where we talk today about SAM and the syntax. So if you're not familiar with SAM, bear with me. It's not important to understand all the details, but the idea is that in your SAM template, where you describe your serverless application and all the components, so my functions, my S3 buckets, my DynamoDB tables, you can include now a serverless application like this. So tweet source is a serverless application. It's not something that I want to build, but it's referencing this application that is in the repository. So you get in the repository the ARN, the unique Amazon resource name that is linked to this application. So I say I want to use this application. Those are the parameters of the application. You get the parameters from the description of the application. So you need to provide a search text, and this is the syntax of the Twitter search API. So I need to search for serverless native tweets and retweets. I want to run this every minute. The batch size, I want to get 15 tweets at the time, and the result must be passed to this Twitter processor function name, and this is your function that normally is declared before or after in the template. So in your template, you really need to say, this is my function, and this is the code of the function. And then you say, this is part of this application and must be invoked when there are tweets available. So you don't need to copy, paste anything. You just, in your code, reference an application that is in the repo and integrate that with your custom function. I don't know if this is simplifying or making things more complex for you, but to me, this example really gave me the idea of what you can build. And we're really looking forward to see what kind of components customers we're going to build in the repository to be reusable in this way. With this, this is the end of the first session. We have a few minutes, so questions are more than welcome. And after this session, we have a short break of 30 minutes, and then we start again at 11:30. So, any question? Thank you. Any question on what we saw? Yeah?
You mentioned about the Amazon recognition and AI service, and it's able to do sentiment, so you're able to use the lambdas to grab the sentiment, or?
So we have a few machine learning services that are they can be defined serverless because you use them as an API. Amazon recognition can analyze pictures and videos, and can look, for example, what are the objects in the picture or the video. It can also recognize faces and can look at the sentiment of the faces. So if the face is happy, sad, and so on. We also have another service that is Amazon Comprehend that can analyze text. So for example, for tweets or articles, you can analyze the text. You can find entities. You can find also the structure of the text. And we can find what are the main topics. And we can also look into the sentiment of the text. So you can extract sentiment from visual information or from text information, and so it's quite powerful. And we are adding support for multiple languages, but probably most of the audience here is interested in English, so that's easier. When I talk in other countries, sometimes I say, is this language supported? Is this language supported? So for English, we have full support, also for Spanish. And we added support for lots of other languages, for example, in Comprehend. And we also have translate, so some customers, they translate maybe from languages that we don't support in Comprehend. For example, from Polish, you can translate to English and then do the sentiment analysis in English. Even if the transaction is not perfect, the automatic transaction, for sentiment analysis is more than enough. Any other question? Yeah? So the question is there any use case where you would not recommend Lambda? So I'm quite a big advocate, and sometimes I create maybe more complex things trying to use Lambda than without. But the idea is that anything that is event-driven fits very well because you can react. So that's the native use case. I was thinking now with a customer who wants to download stuff on S3, for example, from an external website. So do that with Lambda. If you have a very large object that can require more than 15 minutes, you need to manage the state of the download. So everything that is longer than 15 minutes must be partitionable. So if you can take an activity that takes a few hours, and you can partition that in chunks, logical chunks that can run within 15 minutes, then it's a good fit. Otherwise, if you start to see that it's complex, it's probably not a good fit. For everything that you see that is not a good fit, give us the feedback, because as you saw, one of the purposes of our features is to help customers build new things. Another use case that maybe if you have a very high volume website and you put it on the API gateway, it can be expensive because it's not designed, the API gateway is very, it has lots of features for API management. It's not just a web server. So in that case, look for maybe different architectures. You can use Lambda, maybe invoke directly from JavaScript in the page and not through the API gateway. So there are other ways to do that. There was another question there, OK?
Yeah, so you mentioned about asynchronous invocations for Lambdas. So if the Lambda functions have to work on, say, distributed partition from upstream, say, event streams, from event to event. So how do you manage the partition data for multiple functions? Can you actually provide in terms of how they coordinate between the distributed messages that you work on?
So what kind of partition are you referring to?
So let's say for Kinesis streams in terms of the
OK, yeah. So the question is how you can manage Kinesis streams, for example, with partitions where you want to preserve order and have asynchronous invocations. So if you have asynchronous invocation, order by default is not granted. So if you upload 1,000 files on S3 and these files 1,000 Lambda functions, you can't understand which is the order. For streaming operations like Kinesis streams and DynamoDB streams, we have a different setup. That is, we manage it internally to the Lambda platform, and we do the polling for you, and we preserve the order in that way. So it's actually not an asynchronous invocation. There are technically 3 ways of invoking a Lambda function. Synchronously, and you get the result, like the API gateway. You call a Lambda function, wait for the result, and then you get the result back. Asynchronously, like S3, you fire a Lambda function to process something. You say, this new object has been uploaded to S3. S3 don't care to get any result. And the third way is stream-based, where we are adding logic inside the AWS, the Lambda service for Kinesis streams and DynamoDB streams. And we use synchronous invocation, but we manage that for you. And that's why now you can use up to 20 Lambda functions, because we use partitioning in that case. So Kinesis streams has the concept of shards. And when we preserve order within a shard. So normally, if you have, for example, an IoT architecture, each device has a device ID, and you want to get the message from a specific device ID in order. You can't be interested in the global order of 1 million of devices. It doesn't make sense. You want to receive the message in order from a specific device. So you use the device ID as partition key with Kinesis. So when you put the data into Kinesis, you say this device ID is your partition key. In this way, the same device ID will always go in the same shard. And then the Lambda function will consume that shard in order. Using our internal implementation, and you can now subscribe up to 20 Lambda functions in order because there is a new functionality in Kinesis that basically is micro-batching and preserving the order in all the listener. OK, I think you deserve a little break. I'm here if anybody wants to ask me a question, and we start with the next section at 11:30, and it will be a dive deep with live demos for Lambda layers and the Lambda runtime API. Thank you.